So just to review here, when a number or a variable is raised to an exponent or has an exponent, we can say that it's raised to the power of that exponent, to the power of. So today we're talking about the power rule. For example, 2 to the 4th, we can say 2 to the power of 4. 2 to the 4th, or 2 to the power of 4. So it's a lot easier to say 2 to the 4th, but technically what we're doing is 2 to the power of 4. So the power rule is our third exponent rule. We got product rule, we got quotient rule, now we got the power rule. So the product rule involved multiplication, right? That's why it's called the product rule. The quotient rule involved division. That's why it was called the quotient rule, right? Quotient is the result of division. So the power rule is going to be when we raise a power to another power. Okay? So if a base raised to a power is then raised to another power, may sound a little confusing at first. Come on guys, focus up please. Okay. All we're going to do, just like always, is keep the base the same but now instead of adding the exponents or subtracting the exponents, what do you think we're going to do with the exponents? Multiply them, exactly. It's the natural next step. Let me spell this right. Multiply. There we go. Multiply the exponents. Like I said, in the textbook, all these rules are in the same lesson. So if we did all these the same day, it would all get real confusing in your head because they're all so similar, yet slightly different. And that little bit of difference, yeah, makes a world of difference, you know. So let's see what I even mean by all this. For example, you can keep writing this down. I know some of you are still writing. I'm going to get this first example started here. We have 2 to the power of 3 raised to the power of 4. That's kind of what it looks like. We've got a base with an exponent inside parentheses with an additional exponent or another power on the outside of our parentheses, like that. Does anyone remember the term when we have something outside the parentheses that we then multiply by what's inside the parentheses? Starts with a D. Does anyone remember that term? Maybe you learned it last year. Division is close. Starts with a DI. No. Division is close. Dividend? Oh, that's a good word. I haven't heard that word in a long time. Divide? I'm not even sure what a dividend is, to be honest. I think it has to do with division, but that's close. Divide is close. DIS, does that help?
Distribute.
Distribute, there we go. So what we're going to do essentially is distribute this 4 to the 3. We'll talk more about distributing later. It's not too important right now, but here's what's going to happen. We keep the base the same, 2, and we take our exponents 3 and 4, and we just multiply them together like that. I'm going to zoom in here so we can see better. 2 to the power of 3 times 4. Okay? Now what is 3 times 4? 12. 2 to the power of 12 is what we get. It's going to take us forever to multiply 2 by itself 12 times, so we can leave it just like that. Not too bad, hopefully?
Yep.
Good. Like I said, very similar to what we're doing. The only thing we're changing in each of these different rules is what we do with our exponents. On Monday, we added the exponents. On Tuesday, we subtracted the exponents. Now here on Wednesday, we are multiplying the exponents together. I'm going to ask the same question. Why does this work? Because it should be how does this work, but I already started with why does this work, so we're going to go with that. Why does this work? Bless you.
Why does this work?
I think so. To figure out why or how, bless you, this works, we got to expand, just like always. I'm going to move this up. So we're going to keep that same example, 2 to the power of 3 raised to the power of 4. Now let's focus on this outside exponent. If we're raising this quantity to the power of 4, how many times would we write out that inside quantity? If we're raising it to the power of 4. We're going to write out 4 times. Thank you. So that's going to look like 2 to the third times 2 to the third times 2 to the third times 2 to the third. That's our first layer of expanding. This work is kind of like an onion. You can just keep peeling back the layers. There's our first layer. We got rid of that outside or external exponent. Now we can expand all these 2, but before I do that, does that make sense how I did that? Right? 2 to the third 4 times. 1, 2, 3, 4. Expand that out. Okay. Now what if we expanded 2 to the third? What would 2 to the third look like? 2 times 2 times 2. This 2 to the third is going to look like 2 times 2 times 2. This 2 to the third is going to look like 2 times 2 times 2. And finally, we've got one more 2 times 2 times 2. It's a lot of work. It's a lot of expanding. Are you guys okay? Okay, get it together, please. Thank you. A lot of expanding, a lot of 2's, right? How many total 2's do we have down here now? We got 12 of them, right? 12 2's total. Therefore, our answer would be 2 to the power of what? 12, right? We have 12 2's together. We bring them all in. We get 2 to the power of 12. But again, all this expanding, that's a whole lot of work. If we can just multiply those exponents, that's a nice, neat, shortcut for us, right? Any questions about how we expanded that out? I know it's a lot to take in, but hopefully you see the progression there. Let's take a look at another example. Say we've got x to the power of 2 raised to the power of -2. Now your brain may look at that negative exponent and immediately go, oh, let's put this over 1, flip it around, and do all that. But let's wait a second. Because we're raising a power to a power. So let's clear that out of the way first, and then we'll deal with our negative exponent after that. Okay, it's going to be a lot neater when we do that. We're going to multiply the outside exponent by the inside exponent. And we get x to the power of 2 times negative 2. Right? That's our power rule. We multiply the exponents together. What do we get when we multiply 2 times negative 2?
1 x to the power of negative 4.
That's right, x to the power of negative 4. 2 times negative 2 gives us negative 4. 2 times 2 obviously is 4, and a positive times a negative gives us a what?
A negative.
A negative, good. Everyone with me so far? Give me a thumbs up if you're with me so far. Good. Good. Now let's take care of this negative exponent. What are we going to do with our base of x first? Put it over 1. Then what are we going to do? Flip it around. Good. Glad we remember. We've been doing it every day, which is nice. 1 over x to the negative 4th. Then turns into,
The negative 4 to a positive.
that's right, our negative 4 turns into a positive 4, and we get 1 over x to the 4th power. Again, all these answers look the same as the answers we've been getting on worksheets 5 and 4. Just be sure that you are multiplying the exponents here when we raise a power to a power. All right, 2 more examples, and then we'll get started. We'll have tons of time to get finished up. So we got back to school night tonight. Let's do, how about 5 to the power of negative 5
To a power.
raised to the power of
Negative 4.
negative 2.
Wait, so notes take 20 minutes every day?
Typically. Today they'll probably end at like 17 if we can breeze through this, but think about it, if we have a 90-minute class, 20 minutes is like what? Like 25% of the class, I think? No.
Right?
20, 40. Yeah, pretty much. It's not that bad. I've had teachers that spend 90 minutes on notes. You know what I mean? So, we don't have that much to talk about, though. 5 to the negative 5, raised to the power of negative 2. What am I going to do with that negative 5 and that negative 2 there?
You multiply them both.
We multiply them by each other. So we keep our base the same. We distribute that negative 2 down.
And negative.
And we get negative 5 times negative 2. I'm going to put parentheses around them
Do we have
because
to-
now we're multiplying,
do we
right?
have to put the parentheses around?
I would suggest putting the parentheses because before we were adding and subtracting, right? So we didn't need parentheses because we wanted to combine these signs in the middle. But we can't combine a multiplication and a subtraction sign together. We just have to keep in mind that a negative times a negative would equal a what?
Positive.
A positive, right? So what would negative 5 times negative 2 give us as a new exponent? Positive 10. That's right, Francisco. Positive 10. There's our answer.
So it'd be 5. 5 times 5 times 5.
It'll be 5 to the power of 10. Way too big of a number for us to worry about. We'll leave it like that. So we did a positive times a positive in the first example. We did a positive times a negative in the second example. And we did a negative times a negative in the third example. So when you get to the worksheet, you're going to see a mixture of a bunch. Like here's negative times positive, positive times positive, negative times negative. So use these examples to guide your work on the worksheet if you need to. One last example and we'll get started. This one will be nice and short. Let's say we have, what letter do I want to use? Let's go y to the power of 7 raised to the power of 0. Go ahead and copy that down. A lot of you can already figure out what this is going to be in your head, hopefully. What's my base here?
Y.
Y. Now this is where things are interesting, right? Because we don't have like bases. We only have one single base. See what I mean? But we really do have like bases. If we go back up to our expansion, right? 2 to the third times 2 to the third times 2 to the third times 2 to the third. What was my like base here? 2. So we do technically have like bases. We just don't need to expand it to the point where we see them all, okay? All we have to do is multiply what times what? 7 times 0. That's just 0, right? Anything times 0 is 0. So we get y to the power of 0, which is equal to, everybody show me on your hands, what is y to the power of 0 going to be equal to? 1, exactly right. Even though we have a variable, right? Because you may be thinking, well, how do we know that it's equal to 1 if we don't know what y is? Y could be anything, big or small, positive or negative. If it's raised to the power of 0, it's going to be equal to 1. So we can simplify it right there, just like that, and we get 1. Up, down, sideways, quick show of thumbs. How do we feel about that power rule there? Good. If you know your multiplication facts, like we did the booklet review last week on, hopefully this will go by nice and quick. Did we hit the 17-minute mark? Yes, we did. Nice. That's what I thought.